Let's show that two non-zero vectors, A and B, are parallel or antiparallel if and only if the cross product between them is zero. So in other words, let's say we have two vectors, vector A and vector B. These two vectors are obviously not parallel. They don't lie along the same line. We want to show that if we do have two vectors that lie along the same line, so either those two vectors are parallel or those two vectors are antiparallel, we want to show that if this is true, then the cross product between them is equal to zero. While in this situation, the cross product between those two vectors won't be equal to zero. So in proving that, let's look at the magnitude of the cross product between these two vectors. The magnitude of the cross product between vectors A and B is equal to the product of the magnitudes of vectors A and B times the sine of the angle between them. Now, for vectors to be parallel, either the angle between those two vectors have to be zero or has to be equal to pi if the sine of the angle between them is equal to zero. Now, you know the sine is equal to zero in one of two conditions. The two conditions are what we just wrote. If the angle is zero, and in this case, the angle between those two vectors, A and B, is zero, or the angle between the two vectors is equal to 180 degrees, or pi. So in other words, if the sine of the angle between the two vectors is equal to the magnitude of the cross product between the two vectors over the product of the magnitudes of the two vectors must be equal to zero if those vectors lie along the same line. So what this means is the magnitude of the cross product of those two vectors must be equal to zero. And if the two vectors are not zero vectors themselves, then what this means is that the cross product between those two vectors must be zero if the vectors lie along the same line.